Here I will mention about what is smart dust and the application areas of this. First, smart dust is very many small micro electromechanical systems, sensors, robots, or etc. Detect light, temperature, vibration, magnetism, or chemical. And smart dust is tiny device with extensive application in science and the technology. So, smart dust uses modes. What is modes actually? A network of sensors made up of tiny wireless computer systems called modes. Modes various data that include light, vibration, temperature, pressure, etc. A lot of things. Think about modes acting like very small microscopic eyes, ears, and arms. These modes could move around the world and collect all kinds of data. How smart dust useful in theory? In theory, smart dust could revolution industries by reaching place scientists never thought possible. Now, I want to mention about application of smart dust, but first, how smart dust works. Smart dust devices work without any human intervention as they are programmed before. So you don't need to do anything while using smart dust. I want to mention about these applications. The first applications area is the industry. Continuous monitoring of essential equipment, also assessing the exact condition of machines and their weakness can prevent complete system failure. So is the first part is the monitoring actually. Second application area is the security. Wireless monitoring of the suspicious people. Again, the monitoring is the key part. The third part is the controlling inventory. Taking product from their manufacturers to retail shelves via transport facilities would ensure tight inventory control. The fourth part is the medical diagnosis. Is very useful in the medical areas. And research in US Berkeley have highlighted how brain functionalities can be studied with implemented neural data. The fifth one is the transport sector. Smart dust perishable goods as these materials require constant monitoring. So this is the monitoring again the key part. So you can monitor everything with using the smart dust. The sixth part is the military applications. It helps accessing activities in remote and or inaccessible areas. So thanks to smart dust, there are a lot of areas can be shown for human. And the last part is the travel safety. Smart dust technology can play a vital role in ensuring safe traveling. For example, you want to go to somewhere and you don't know how the road situation is. Thanks to smart dust, you can get information about the road. Is it rainy or is it snowy or something like that. So you can get a lot of information about the road and you can drive safely. So also large companies such as Cargill, General Electric, Cisco Systems, and IBM have invested sustainably in smart dust research. The last part that I want to mention about is the future. There I want to mention about two important areas: health and the weather. For example, just imagine in health sector, tiny robot chips drifting through a human artery to locate and eradicate a hidden clot. And the other application is will be the cloud of sand. Each of the size of grain of sand blown a lot by hurricane winds and the relying data on storm to weather station below.
Today I'm going to represent the machines in nanotechnology. First of all, I want to start with a question: what is machines in nanotechnology? Machines in nanotechnology is an emerging technology field creating machines or robots whose components are near nanometer. Nanomachines remind actual DNA, RNA, and ribosomes in human body. Once a book I read about nanotechnology, which is written by Ray Kurzweil, thinks that nanobots are the future for life, and the book tells us that we will see humanized robots with fine details, and it can be help of the nanotechnology. 3D printing. It's additive manufacturing is making 3D objects by building with digital design. The objects are produced more precisely. Even bioprinting tissue can be made independent of complexity of their shapes. And actually, in the beginning of the presentation, what I tried to say, as we see on the picture, 3D printing can now be used to print lithium-ion microbatteries the size of a grain of sand. These are made by Harvard and Illinois University. Printing two-dimensional objects with incredible fine detail is already possible using a direct laser writing method called two-photon lithography. By San Diego University, they fabricated 3D piezoelectric materials that relies on piezoelectric nanoparticles embedded in. What I try to tell you that piezoelectricity is the electric charge that accumulates in certain solid materials in response to applied mechanical stress. In electronic, we have piezo buzzer that have similar principle that produces sound. By help 3D printing, as we see on the picture, it enables the feasibility of cloud structures for electromechanical transfer by flexible chips. Recently, carbon-based nanomaterials such as graphene and carbon nanotubes (CNTs) have been applied in the field of bioelectronics because of their physical structures. The various types of flexible and substrates that use CNTs and graphene for active electrode arrays and sensors. Wearable electronics consist of sensors, actuators, electronics, and power supply or generation. They have unique characteristics such as lightweight, highly flexible, and stretchable. A textile and smart fabric is helping application of wearable actuators. Flexible sensors are very important in cardiovascular diseases such as heart pulse, and they analyze the sweat, tear, blood, etc. Flexibility is a major breakthrough in the world of electronics, which will enable a new paradigm in design and functionality for devices or modern life depend on solar panels. Nanotechnology can help with design and manufacture second-generation thin film PV cells. However, nanomaterials will truly come into their own in the third generation of solar cell technologies. Current solar cells cannot convert all the incoming light into usable energy because some of the light can escape back out of in the air, or they cannot absorb all types of colors. Integrating a high quality film of silicon nanoparticles improves power performance by almost 6% in the ultraviolet range of the spectrum. Another starting point for the increase of conversion efficiency of solar cells is the use of semiconductor quantum dots, which is QD. By means of quantum dots, the band gap can be used to convert also longer wave light. Potential advantages of these cells are higher light absorption in the particle in the infrared spectral region. Another important property of dots are being heat carrier. A successful company created a solar panel by reducing the cost of production from $3 a watt to mere 30 cents per watt. Actually, production of the actual solar panel is not cheap, but in the time we will see it's cheaper. And another disadvantage of solar panels are complex matrices, because there are many dots and they cannot control the energy of the automotive sector. Nanomaterials for automotive applications are intended to pursue reductions in engines emissions, safe driving. Global expectation for fuel economy are creating a demand for a new low-cost, high-performance, lightweight materials. Nanotechnology can contribute to improve fuel injection and reforming to hydrogen storage. Due to better nanomaterials, hydrogen production, storage, and transformation into electricity in fuel cells are being improved with more efficient catalysts for water splitting. An efficient storage medium for hydrogen is required to reduce the tank volume down to 10% of present hydrogen pressure tanks. The future development of new electric vehicle models is strongly influenced by advancement of long life, fast charging, and better capacity batteries. Ultracapacitors, when compared with conventional batteries, offer for many years without degradation and can tolerate cold weather conditions. Nanoproducts application have uncertainties regarding environment impacts. For example, as another disadvantage, nanoparticles can penetrate in the human body and it can create toxicity, and it's the disadvantage of nanotechnology in automobile sector.
I'm going to introduce you computing and how nanotechnology affects and changes the computing area. First, computing is any goal-oriented activity requiring benefit from or creating computer machinery. It includes study of algorithm processes and development of the both hardware and software. It has scientific engineering, mathematical, technological, and social aspects. Major computing fields include computer engineering, computer science, cybersecurity, data science, information systems, information technology, and software engineering. Computing includes study of algorithm processes and develop of both hardware and software. First, I'm going to explain the hardware. Hardware includes the physical parts of the computer, including central process unit, memory, and input-output. Importance topic in the field of the computer hardware are computational logic and computer architecture. Second main topic is software. Software is also sometimes used in more narrow sense. Software is also sometimes used in the more narrow sense, meaning application software only. In contrast to hardware, software is intangible. I mean, you can see in your daily life. In the collection of the computer programs and related data that provide the instruction for telling a computer what to do it and how to do it. And we can separate the software into three topics. First topic is system software. As you know, like Windows, Android, and iOS. The second one is application software. Is a Word document, PowerPoint, Office, and etc. The last one is programming languages like MATLAB, C++, Python, and so on. And nowadays, how nanotechnology affects the computing. The use of carbon nanotubes is the one technology that looks able to maintain the current pace of technological advancement by providing a sensible approach to smaller, faster transistors. IBM is the one major player playing to have transistor built using carbon nanotubes that are able to take control from silicon transistors soon, 2020s. When silicon-based transistors are anticipated to reach their limit, the target for a new type of transistor is founded on the timetable of the technical advancement. The chip industry has planned out to sustain Moore's law. The prediction that amounts of transistor that might be packed into circuit would every 2 years. Generation of computers chip engineering are known by the size of the tiniest structure that can put into a chip. The current best is less than 10 nanometers, and by the end of the decade, to be able to keep up Moore's law, the industry will have to be down 5 nanometers from the 10 nanometer. IBM's design makes use of 6 nanotubes arranged in parallel to create a single transistor. Each nanotube is 1.4 nanometers wide and about 30 nanometers long, and space approximately 8 nanometers apart from the its cells. Both ends of the tubes are rotated in electrodes that provide current leaving about 10 nanometers of their length uncovered in the middle. A third electron expands perpendicularly under that. It's part of the tube and switch transistors on and off its sign key digital 1 and 0. And finally, how it will change in the future, how nanotechnology affect computing. Generally, as you know, silicon is using almost every area of the computing. But in my opinion, in the future, with nanotechnology and nanotechnology's innovations, we will use more suitable and more efficient material instead of silicon in our devices. We mentioned about the computing, and İpek will mention about the medicine and nanotechnology, how affect the medicine.
Finally, nanomedicine. First of all, what is nanomedicine? It is medical applications of nanotechnology, and it ranges from the medical applications of nanomaterials and biological devices. So, what is the applications of nanomedicine? Disease diagnosis, detection, monitoring, drug delivery, nanosurgery, targeted therapy, and drug screening. Before learning what is nanomedicine, we need to learn nanoparticles because they are really essential for us. First thing is dendrimer. The second one, protein drug conjugates, polymer particle, liposome, hydrogel particle, solid lipid hybrid particle. I want to mention about dendrimer because dendrimer and liposome are really useful for the cancer therapy. Then dendrimer can transport large amount of drugs to specific area, and for the liposome, it can overcome the limitations of conventional chemotherapy by improving the stability of the drug molecules and minimizing the side effects by targeted delivery of the drug. These nanoparticles have lots of advantages such as dose reduction, controlled drug release, enhanced delivery. We are trying to minimize the side effects with using nanoparticles. So, first thing is drug delivery. What is drug delivery? We learned nanoparticles and they are engineered so that they know where to go. Disease cells, tumor detection, or anything. So this technique reduces the damage to healthy cells in the body and early detection. It supplies us early detection, and in diagnostic part, early detection means early treatment, and this is really essential for us. And I had research about kidney. In the future, actually, we will see it, but I want to mention it. For the kidney damage, the researchers use gold nanorods. Why they use gold nanorods? Because gold nanorods function, they are attached to the protein which generated by the damaged kidney. When protein accumulates on the nanorod, the color of the nanorod will change and it will allow us the detection. And this is, I think, really interesting thing I want to share with you. This chip is called nanorobot. It includes drug and it is used in surgery. The blue thing is the drug, and the nanorobot knows where to go, where is the disease cells, where is the tumor, and it just go there and leave the drug there. And cancer is the really bad illnesses, and we have some current treatments for the cancer: surgery, radiation, chemotherapy, and hormone therapy. But with nanomedicine in cancer therapy, they are not just kill the disease cells, they also kill the healthy cells. But with nanomedicine, we are trying to just focusing on the disease cells. The nanoparticles attach with the proteins, with damaged proteins from the brain or what is the cancer type, and then they heal it. And they detect it, and and then we reach the treatment actually.
We try to explain what is nanotechnology and what is the four main topic of the nanotechnology. And we explained smart dust, machines, computing, and medicines with the relation with the nanotechnology areas. Thank you for listening. If you have a question, we can answer it.